In this video, we're going to continue in the review of logarithms. So the first thing that we're going to review on this video is how to convert between the forms. So for the first, we're going to look at exponential form. So I put this as b because it's the base of the exponent, so b raised to the y power equals x. And the way that we rewrite the form is we always start with the base. So I'm going to write log base b, so the base of the exponent and the base of the log come from the same number. And then we go around, and I've heard this called the Tootsie Roll, or the Scorpion, or the Swirl, or the Cloud, or the, there's a million different names for it. But basically all you're doing is converting, and you kind of go in a circular motion. So log base b of x equals y. So for example, if we had 81 is the same as 3 to the 4 as the exponent, then when we rewrite this in log form, we would start with the base. So log with a base of 3, and this one is set up the opposite way, and so it just means I'm going to go the opposite way as I go in that circular motion. Like that. Okay. If we start off with log form, then we'd say log base b of x equals y. They match. And again, we start with a base. So the base of the log becomes the base of the exponent, and then we do that same circular motion again. And so over here, for an example, if I had log base 2 of 32 equals 5, then my base becomes the base, and then I do that circle. So 2 to the 5th equals 32. And since we can think of in terms of exponents more easily than in terms of logs, you should be thinking, oh yeah, 2 to the 5th is 32. That makes sense. Okay, so next we're going to look at finding inverses of the logarithmic or exponential functions. So in a previous video, I talked about the exponential equation y equals negative 2 times 3 to the x plus 1 minus 4. And so if you look at that on a graph, struggle bus, to the x plus 1 minus 4. That's what it looks like, and it has a horizontal asymptote of negative 4. And so I'm going to go ahead and draw a sketch on here. There we go, so you can see it. Horizontal asymptote right here, and it's something like this. So over here I'm writing horizontal asymptote, y equals negative 4. Now, if we look at this graph, we're going to notice that the domain here is negative infinity to infinity, and the range is from negative infinity up to negative 4, and it does not include negative 4. Okay, so if I was finding the inverse of this exponential function, then what I'm going to do is trade the x and the y. And then I want to solve for the y. And this one should feel kind of complicated because you probably have never really done this before. So basically what I need to do is if I'm going to isolate the exponent, so let's look back up here, the way that I do that is by switching it into log form. So I'm actually going to eventually, when I find the inverse of this, it's going to be in log form because exponentials and logs are inverses of each other. So what my goal is, I need to rewrite the problem so it's a base to an exponent equals something on the other side. And right now I have a base to an exponent, but I have a lot of extras, and so I have to move that stuff to the other side before I can do the converting of the form. So I added the 4 over. Now I can divide by negative 2. And people typically, mathematicians, do not leave negatives on the bottom of fractions. They usually move it to the top. And if I move it to the top, then it's going to apply to both of these pieces on the top. So I'm going to rewrite this as negative x minus 4 over 2. If you left it as negative 2, you are not mathematically wrong. It's just that if you were to check your answer in like the back of a book or with an answer key, this would be the typical answer. Okay, so we've got that, and then we've got 3 to the y plus 1. And at this point, my base is all alone with my exponent, so now I can do that Tootsie Roll or Scorpion or whatever you want to call it. So the base of my log is a 3, so I've got log base 3 of this stuff, so negative x minus 4 over 2 equals y plus 1. And I am almost finished. I just have to move that 1 over to the other side. So I have log base 3 of this stuff minus 1 on the end equals y. And since this is the inverse, I'm going to put a little inverse, y inverse. Alright, and then when you find the domain and the range of the inverse function, you just have to look at the original domain and range and switch them, because you switched your x and y, so your domain and range should trade as well. So here my range would be negative infinity to infinity, and my domain would be negative infinity to negative 4. Alright, and I'm going to go ahead and graph that on here so you guys can see it. So if you have a newer calculator, you can hit math, and then go up from the bottom, and we can type in log base. And we're going to do log with a base of 3. And I've got negative x minus 4 over 2 minus 1. And if you guys remember, it would keep coming down to go like this. And if you guys remember, these are symmetric over the line y equals x. And my screen is not quite square, it's rectangular, which is why this doesn't look very nice. But if we had a square screen and we were able to draw that diagonal, then it would be going through the midpoint of that, and then you could see they're symmetric on each side. So that is the inverse there. Alright, and we're also going to look at the inverse if you're starting with a logarithmic function. So in that same previous video that I talked about, we had looked at the function y equals 1/2 log base 2 of x plus 3 minus 1. And on this one, we'll go ahead and graph it. 1/2 log base 2 of x plus 3 minus 1. So this one's going to have a vertical asymptote at negative 3. And then it looks something like that-ish. Alright, so if we look at the domain here, we're going to say the domain is from negative 3 to infinity, and the range is from negative infinity to infinity. And then we're going to do the same thing that we did with the exponential graph, where we're going to trade the x and the y. And I'm going to start to move everything away from the y value. So I'm going to add 1 to the other side. X plus 1 equals 1/2 log base 2 of y plus 3. And you'll notice this is the same deal as what we kind of had in the last example, where before we can do that Tootsie Roll or Scorpion or whatever you want to call it, the log with the base has to be by itself on this side for us to do it. This side can be a bunch of stuff, that's fine, but this side has to be log base b of something all on its own. So to get rid of the 1/2, I'm just going to take this and multiply it by 2, and that would make those cancel, and take this and multiply it by 2. So I get 2x plus 2 equals log base 2 of y plus 3. And at this point, the log with the base is all alone on that side. So now I can do I call it the Tootsie Roll. My math teacher, I'm pretty sure, called it the circle thing. Like it was some mysterious whatever. Okay, so 2 to the 2x plus 2 equals y plus 3. And then I just need to subtract the 3 over to the other side. And there's my inverse. And to find the domain and range of my inverse, I just need to trade the original domain and range. So the domain here would be negative infinity, infinity, and the range would be negative 3, infinity. And then we can go ahead and graph this just to make sure that our graphs make sense. So 2 to the 2x plus 2 minus 3. And then if you can see, if there was a dotted line that went diagonally in between, then it would be symmetric over that line. Okay, one last thing on this video that we're going to review is property of logs. So there are three properties that we are concerned with. The first is log base b, it could be any base, of m multiplied by n. And this could be expanded to be log base b of m plus log base b of n. Then we have log base b of m divided by n, could be log base b of m minus log base b of n. And this should be reminding you of the laws or the properties of exponents, right? If you multiply two exponential expressions where the base is the same, you add the exponents. And so it's kind of like the backwards version of that, which would make sense because these are inverses of that. So if it seems familiar, it should be. And then the last one is if we have log base b of m raised to the n exponent, you can put the n in the front and then say log base b of m. So this part on the left side is called the condensed form, and the part on the right is called the expanded form. And different forms are good for different things. We will typically start with the expanded form and turn it into the condensed form, and we're going to be using that later when we solve equations, if you guys recall that from your previous math classes. So note to self, this also works for natural logs, which is ln, because natural log ln is really just a log with a base of e. So all the log rules would still apply because it really is a log. We just don't write it using the letters log. Okay, so next we're going to do just two examples of using the properties. So my first example is going to be, we want to expand the expression log base 3 of x squared plus 2x divided by 3. So what you might be noticing is that the top of this can be factored, and so I'm going to do that first because that's going to help me see what things are multiplied by each other, and multiplication was one of those properties. So I factored out a GCF of x, and then I have an x plus 2 left over. And so now I just have to recall that these two things are multiplied, which means I'm going to rewrite it as adding. So log base 3 of x plus log base 3 of x plus 2. And then that 3 is being divided, so then I'm going to say minus log base 3 of 3. So however many terms you have kind of in here, that's how many times you write the word log. So this is 1, 2, and 3, and so we wrote log 3 times. All right, and then last we're going to say we want to condense this expression, and it's going to be log base 4 of x minus 5 times log base 4 of x minus 6 minus log base 4, sorry, there's a 7, minus 7 log base 4 of x. So when we condense, we only get to write the word log one time. So log base 4, that's the only time I get to write it, and it's going to apply to the whole problem. And I always start, this first thing is going to tell me to start on the top of the fraction, so I'm starting there. And then these two things are both minuses, so they both mean move that to the bottom of the fraction. So nothing else gets to be on the top. So this is going to be x minus 6 to the 5th power, because numbers in the front become exponents. So x minus 6 to the 5th power. And then this part right here is going to be x to the 7th. Oh, let me put it right in front. X to the 7th like that.